Every time you go online, your data takes a little journey. Let's see how to keep it safe. And that journey happens in a flash between your device and a server somewhere out there. It all starts with your device. You type something in, and bam, it sends out a request. That request zips over to a website server, which then sends the website content right back to you. But this journey has its dangers, so let's talk about our first line of defense, the technology shield. Always, always look for that little padlock in HTTPS. That S stands for secure, super important. HTTPS scrambles your data into a secret code, so while it's traveling, no one can read it. Yeah, it's kind of like sending a locked box. Even if a hacker grabs it, they can't get inside. All right, next up, security software. Think of it as your own personal digital bodyguard, always on watch. Its job? To stop all the nasty stuff, viruses, malware, you name it, before it even gets to you. But here's the thing, tech can only do so much. The most important shield? Well, that's you. So, let's go over 3 key habits that put you in charge. First up, let's talk passwords. Yeah, weak passwords are just an open door. Something like this, though. Now that's tough to crack. You want to aim for at least 12 characters and use a different one for every account. Trust me. Okay, number 2, dive into your privacy settings. A lot of apps default to making you public. Decide who sees your profile and seriously turn off location sharing for any app that doesn't need it. And number 3, learn to spot phishing. That's when you get fake links designed to steal your info. Watch out for messages trying to make you panic. If something feels off, just don't click it. So you see, it's technology plus your own smart habits. That's what creates a truly complete shield. So the real question is your personal shield as strong as it could be? Something to think about.
Every photo you take, every doc you write, it all has to go somewhere, right? And how do you get that same file on all your different devices? Let's find out. We're going to trace your data's journey from inside your laptop all the way to the cloud. Okay, so everything kicks off right here on your device. When you hit save, that file needs a permanent home so it doesn't just disappear. And that's the job of the SSD, which stands for solid-state drive. Unlike old spinning drives, an SSD has 0 moving parts. It's way faster and tougher. So what's the magic inside? Well, it all comes down to 2 key parts. First, you've got NAND flash memory. It's made of millions of tiny little storage cells. Each cell holds a charge for a 1 or no charge for a 0. That's binary code. Every single one of your files is just a long string of these 1s and 0s. The second key part is the controller. You can think of it as the brain. It tells the data exactly where to go and remembers where to find it later. And just like that, your file is safe and sound on the SSD even when it's off. But what if you need that file on, say, your phone or another computer? That's where the cloud comes into play. Let's see how that part works. When you upload a file, your device shoots that data right across the internet. It travels to a cloud server, which lives inside these huge secure data centers. And the real power here? Being able to get your files from literally anywhere. Because it lives online, you can just download it to any of your connected devices. It's why you can start homework on your laptop and finish it on your phone. So, let's do a quick recap. You save a file, and the controller writes it to your local SSD. Then, you upload it to a cloud server so you can access it anywhere, anytime. Simple. Ever wonder how a digital camera actually takes a picture? Well, it all begins with light. So, let's follow how a camera turns that light into a photo you can share. This diagram shows the whole journey we're about to take, from start to finish. There are 6 key steps, and believe it or not, they happen in a split second. It all kicks off with light bouncing off a scene, carrying all that color information. First up, that light hits the lens, which is designed to gather and focus it perfectly. And the quality of that glass, that's what makes a photo look sharp and detailed. Next, the light has to pass through the aperture, which controls how much gets in. A wide-open aperture blurs the background. A narrow one keeps almost everything sharp. Just think of it like the pupil of your eye. It adjusts depending on the light. After the lens, the focused light hits the image sensor, a chip with millions of pixels. Each tiny pixel is covered with a red, green, or blue filter to capture color. And here's where the real magic happens. Physical light becomes an electrical signal. So, brighter light creates a stronger signal, dimmer light, a weaker one. Simple, right? All those tiny signals get sent to the camera's brain, the powerful image processor. The processor's job is to turn every single one of those signals into digital data. Then, it instantly makes adjustments, fixing colors, sharpening details, and reducing any noise. Once all of that's done, the final image file gets saved right onto a memory card. And there you have it, the final image ready to be viewed, edited, and shared. That whole amazing journey from a ray of light to a digital file happens unbelievably fast. So, with technology always changing, which part of this process do you think will be next? You know, a smart TV isn't just a screen. It's actually a computer in disguise. So how does it get shows from the internet to your living room? Let's dive in. Okay, let's start with the part you see every day, the display panel. If we get really close, you'll see the pixel grid. It builds everything on screen. Every pixel has 3 even tinier subpixels, one red, one green, and one blue. By mixing just those 3 colors, your TV can create pretty much any color we can see. On a 4K TV, that's over 24 million of these tiny elements, making the picture super sharp. But the real magic happens behind the screen. Let's look at the smart parts. Meet the processor, or CPU. This is the brain of the whole operation. It's what launches your apps, decodes video, and understands your remote control. Helping the processor out is the memory. Think of it like the TV's short-term scratch pad. That's why more memory makes switching between apps feel so much smoother and faster. Now, how does it get online? That's the job of the tiny Wi-Fi module. This little chip talks to your home router using radio waves, all without any cables. So, how does streaming actually work? Your TV just asks a server for the show you picked. Unlike a download, streaming data arrives in real time, so you can start watching in seconds. The processor decodes that data, sending pictures to the screen and sound to the speakers. And those speakers, they turn electrical signals into the sound waves you hear as dialogue and music. So let's put it all together and trace the entire journey from the cloud to your screen. The Wi-Fi gets the signal, the processor decodes it, and sends the video and audio out. And all of this happens instantly the moment you hit play. Pretty amazing, isn't it? Ever wondered what really happens inside an ATM? We're going to break it all down. We use them all the time, right? But what's the secret to how they work? So let's follow the journey of one transaction from your card to your cash. It all begins the moment you insert your card into the internal card reader. This reader scans the chip or magnetic stripe on your card to identify you. So let's take a look at the key components working together behind the scenes. Meet the processor. It's basically the brain of the whole operation, controlling everything. And the network module. Think of it as a secure messenger to your bank. Okay, so how do these parts actually work together? It all happens in a flash. It's a super fast process that follows these exact steps every single time. Before any data travels, it gets encrypted, turned into a secure secret code. This secret code is absolutely crucial for keeping your information completely safe. Once that approval comes back from the bank, the machine's mechanical side takes over. The cash itself is stored in these super secure boxes called cassettes. Next, the cash dispenser, a precise system of rollers and belts, springs into action. This system pulls the correct bills and pushes them right out to the cash slot. So, let's do a quick recap of the entire process from start to finish. It's a perfect blend of hardware, networking, and some very precise mechanics. And all of that happens in just seconds. Pretty incredible when you think about it. Ever wondered how a CCTV camera actually works? Well, let's take a look inside. You see them pretty much everywhere. But how do they see and record our world? Let's find out. Okay, so it all starts with what the camera can physically see. We call this its field of view. It's doing what's called live monitoring, constantly watching and recording everything that happens in that area. But you know, the real magic is happening inside the camera itself. Let's take a look. First up, light from the scene enters the lens. You can think of it like the camera's eye. That lens focuses all the light onto a tiny electronic chip. This is the image sensor. The sensor's job is to turn light into an electronic video signal, getting it ready for the next step. Now, a lot of modern cameras also have a motion sensor. And this is pretty cool because it lets the camera know when something moves, which can automatically trigger a recording or an alert. So, that raw video signal gets sent straight to the camera's brain, the processor. The processor takes that signal, shrinks it down, and turns it into neat digital video data. Next, the network module sends this data out, either through a wire or wirelessly. So where does all that footage go? Well, it's usually stored in two different ways. One way is local storage, which is basically a hard drive that's kept right there on site. And it can also go to the cloud. That means secure servers online for backup and access from anywhere. And that accessibility brings us to the final piece of the puzzle, remote viewing. This is how you can watch the live or recorded video on your phone, literally from anywhere in the world. So, let's do a quick recap. From light hitting the lens to video appearing on your phone, it's quite a journey. And all of this happens in a flash. It really makes you wonder what advancements are coming next, right? You've seen them everywhere, right? On menus, posters, tickets. They're QR codes. But how does that little square of dots actually store information? Let's break it down. QR stands for Quick Response Code. And yeah, they live up to the name. They were invented back in '94 in Japan, originally just for tracking car parts. It holds way more data than a barcode because it works in 2 dimensions, not just one. Okay, so let's zoom in and see what a QR code is actually made of. Those 3 big squares in the corners, they're called finder patterns. These are super important. They tell your phone where the code is and how it's oriented. That's why you can scan a code from pretty much any angle, even upside out. The rest of the pattern is just a grid of tiny squares called data modules. It's pretty simple. A black square is a 1, and a white square is a 0. All those ones and zeros combine to form the binary code that holds the info. But what if the code is damaged? That's where error correction comes in. Get this, a code can still work even if 30% of it is totally unreadable. This is exactly why you sometimes see logos right in the middle of a QR code. So what's actually happening when you point your phone at one of these? First, your camera grabs the image and finds those 3 big squares to line it up. Then it scans every little dot, turning the pattern into a string of ones and zeros. That binary string gets processed into something readable. We call this the decoded data. And if that data is a website link, your phone just opens it right up. Simple. So to recap, your camera captures the code and uses the finders to orient it. Error correction cleans it up, the binary is decoded, and boom, the link opens. And this all happens in a blink, from a simple pattern to the entire internet.
Ever wonder about that little blue dot on your map? Let's break down the magic behind how it works. So, how does your phone actually know where you are? Well, the answer starts way up in space. It all begins with this huge constellation of satellites constantly circling high above the Earth. GPS started as a US military project, but now it's a free service for everyone around the world. Up there, we've got a fleet of over 30 dedicated GPS satellites zipping around our planet. And at least 24 of them are active at any given time, which is how we get coverage everywhere. These satellites are flying at an incredible altitude. We're talking about 20,200 kilometers up. And their orbits are set up perfectly, so you can always see at least 4 of them from anywhere. Each one is constantly beaming down a signal with 2 key bits of info: its position and the precise time. That radio signal travels at the speed of light, about 300,000 kilometers every single second. Now, your phone isn't sending anything back. It's just a passive listener picking up those signals. The really crucial part is figuring out exactly how long it took for that signal to get to you. Your phone just multiplies that travel time by the speed of light, and boom, it knows the distance. But one satellite only tells you you're somewhere on a huge invisible sphere. Not very helpful yet. Add a second satellite, and your location gets narrowed down to where those 2 spheres overlap, a circle. And a third signal gives us triangulation. It intersects that circle, and bam, there you are. A fourth satellite is often used just to double-check the timing and make things super accurate. And that's how you get your calculated position, your precise latitude, longitude, and even altitude. The whole system is so precise, it can find your location within about 3 to 5 meters. This simple dot powers so much of our daily lives. Think navigation, ride-sharing, all of it. So, in a nutshell, signals from space are timed, distances are calculated, and triangulation finds you. This all happens silently, in just a few seconds. It makes you wonder, what's the next invisible, essential tech? Your private info travels across the internet, where anyone could be watching. So how does it stay safe? The answer is encryption. Let's check it out. Okay, it starts with your message. Right now, it's just plain text, super easy to read. Sending it like this, yeah, that's not safe. Anyone could just grab it and cause trouble. So first things first, we encrypt it. That means we turn it into a secret code. Your phone's encryption module uses a super complex math formula to scramble the text. So transfer approved now looks something like this. Yep, total gibberish. And this scrambled mess can't be unscrambled without a very special secret key. Now it's ready for its journey. This is called secure transmission. As it zips through networks, hackers would only see that useless jumble of characters. Okay, the message has arrived, but it's still scrambled, so how do you read it? Well, that's the job for the decryption module. It's designed to reverse the whole process. But it can't do it alone. It needs the encryption key. Think of it like a secret password. And these keys, whoa, they have more combos than there are atoms in the known universe. Once the right key is used, the decryption module unscrambles the data to reveal the message. And voila! Transfer approved shows up on the screen, exactly as you sent it. So your message was scrambled, sent securely, then unscrambled. Pretty cool, right? And all of this happens in a flash, protecting you every single day online.
Ever wonder how an app actually gets from an idea right onto your phone? Let's break it down. Well, it all starts way before it gets to your phone, with a developer on their computer. They use special programming languages to write the code for every single feature you see. Once the app is finished, it gets uploaded to an app store. Think of it like a giant online marketplace. But it's not available right away. First, it's reviewed to make sure it's safe and works well. After it's approved, you can find it in the App Store and download it with just a tap. And wow, there are millions of apps out there for pretty much anything you can think of. Okay, so the app's on your phone, but how does it actually work when you tap on it? It's all about 3 key layers working together: the app, the OS, and the hardware inside. You see the application layer, but it's the OS and processor that do the real work behind the scenes. The processor is basically the brain of your phone. It's a tiny chip that runs everything. And a lot of apps also connect to the cloud. It's where your data is stored online. This is what lets you sync your data across different devices, keeping everything up to date. So that whole big journey, from the developer's code to the cloud, all comes together with your touch. This entire complex system kicks into gear with every single tap and swipe you make. Pretty cool, right? Now you know the amazing journey that happens behind the screen. You've probably seen one